GPT 5.6 is powerful. That does not mean you should use it for everything. In fact, using the strongest model for every task is one of the easiest ways to waste money. The real skill now is model routing. Model routing means sending each task to the cheapest model that can do it safely. GPT 5.6 makes this concrete because the family has 3 official price tiers. Luna is $1 input and $6 output per million tokens. Terra is $2.50 input and $15 output. Sol is $5 input and $30 output. That means Sol output costs 5 times Luna output. If you use Sol for everything, you're choosing the expensive lane even when the task may not need it. That sounds simple, but it changes everything. Most AI workflows have 3 types of tasks. First, low-risk tasks. These include summaries, rewrites, title ideas, simple explanations, formatting, and rough outlines. Use a cheap or fast model here. Second, medium-risk tasks. These include drafting scripts, writing documentation, creating test cases, explaining modules, and planning small features. Use a balanced model here. Third, high-risk tasks. These include production debugging, security analysis, large refactors, architecture decisions, and agent workflows that can edit files or run commands. Use GPT 5.6 Sol, Fable 5, or another top-tier model here. That is the basic routing playbook.
But developers need one more layer: verification. If the output is easy to verify, you can use a cheaper model. If the output is hard to verify, use a stronger model. For example, generating 10 YouTube titles is easy to check. Use a cheap model. Fixing a subtle database bug is hard to check. Use a stronger model. Summarizing a log file may be low risk. Use a cheap model. Changing authentication code is high risk. Use a strong model and human review. This also applies to Claude Fable 5.
Fable might be excellent, but it still should not handle every task. Save it for judgment-heavy work. Planning, product thinking, architecture, long context reasoning, and careful writing. Use GPT 5.6 for execution-heavy work if it performs better in your tests. Use local models for privacy-sensitive brainstorming and low-risk repo exploration. That gives you a model stack: cheap model for simple work, Fable for reasoning, GPT 5.6 for execution, local model for privacy. The point is not to make the workflow complicated. The point is to stop treating every task like an emergency. If you send everything to the most powerful model, you lose cost control. If you send everything to the cheapest model, you lose quality. Routing gives you both. So before every prompt, ask one question: what is the cheapest model that can safely do this? That question is going to become one of the most valuable AI skills. Here's the actual playbook I would use. Start by tagging every task with 2 labels: risk and verification. Risk means what happens if the answer is wrong. Verification means how easy it is to check. Low risk and easy to verify? Use a cheap model. Low risk but hard to verify? Use a balanced model. High risk and easy to verify? Use a strong model if speed matters, but force proof. High risk and hard to verify? Use the strongest model, narrow the scope, and require human review. This gives you a decision matrix instead of a vibe. For example, writing 10 headline options is low risk and easy to verify. Cheap model. Summarizing a private architecture document may be low risk in output but high sensitivity in data. Local model or approved internal model. Fixing a production auth bug is high risk and hard to verify. Top model, tests, review, and approval. Planning a new product feature is medium risk but hard to verify immediately. A reasoning model like Fable 5 may be a better fit. Building an agent workflow that runs commands is high risk. GPT 5.6 may help, but the system needs guardrails. The goal is not to save pennies. The goal is to avoid using intelligence randomly. Once you think this way, model choice becomes engineering. You're not asking which model is cool. You're asking what level of intelligence, cost, privacy, and verification does this task require. That is how teams will manage AI budgets. That is how AI apps will protect margins. And that is how individual developers will stop burning their best model on tasks a tiny model could have handled. Model routing is not a trick. It is the operating system for serious AI work. To make this practical, write your own routing table. It can be very simple. Task: summarize notes. Model: cheap. Reason: low risk. Task: explain private code. Model: local reason. Privacy. Task: plan architecture. Model: Fable 5. Reason: judgment. Task: execute hard code changes. Model: GPT 5.6. Reason: tool-heavy work. Task: review a risky diff. Model: strongest available plus human. Reason: high risk. Once you have that table, you stop making random choices. You also get better at estimating cost. If your whole week is simple content formatting, you do not need to burn premium model usage. If your week includes complex production bugs, you know where premium usage belongs. This is how AI becomes infrastructure. Infrastructure has policies. Infrastructure has routing. Infrastructure has monitoring. Infrastructure has budgets. AI should too. The people who treat models like toys will keep chasing hype. The people who treat models like infrastructure will build repeatable advantage. Artificial analysis also frames this in cost per task terms, which is more useful than price per token alone. Their GPT 5.6 write-up says Sol Max is about $1.04 per task in their intelligence index, and roughly one-third the cost of Claude Fable 5 for similar level intelligence. Whether that exact result holds in your work is something to test, but the framing is right. Cost per successful task is the metric.